Hi students, so in this video I'm going to just do a bit of an overview of the data booklet section for the topic 2 mechanics. Just looking firstly at these three formulas over here. These are all what we call our equations of motion. We can add one other to this, that V is equal to U plus AT. This comes from the fact that acceleration is equal to your change in velocity over time. Change of velocity you can write as v minus u, where v is your final velocity and u is your initial velocity divided by time. And then rearranging this formula we get to this one. So this is often an important formula. Your average velocity, which we often write like that, is basically your distance or your average speed, distance over time. Your average velocity would be displacement over time. The S we know is our displacement. That's displacement. The U is initial velocity, V is your final velocity, T is your time. Here we have our A. Now in all these formulas are true for uniform accelerated motion, rated motion. So we only look really when we're dealing with formulas where the acceleration is uniform, it's constant. Now when we're dealing with free fall, we replace this A in all these formulas with our G, and that, as we know, is about 9.81 meters per second to the minus 2. Okay, so those are our first three formulas. Let's move on to our next one. So this formula over here, F is equal to ma, is basically Newton's second law, that your force is proportional to the acceleration. This is a resultant force where mass is the constant. P here is your momentum. So your momentum is described as, or defined as, your mass times your velocity. Now the force is equal to the change in momentum over time, and we can rewrite this as Ft, and F times time, change in time, is equal to the change in P. This is often called the impulse, as is discussed there. Now we can actually rewrite Newton's second law of ma, because A is equal to V minus U over T. We get F is equal to mv minus mu over T, and this actually is your change in your change in momentum over time, over your change in time. So Newton's second law can be rewritten as that the force is equal to the rate of change of momentum. Your impulse is basically just looks at that the force times the time that the force acted on the body is equal to the change in momentum. We can write that also as a change of momentum. Alright, good. So that's to do with force, Newton's second law, and impulse and momentum. Let's now move on to this formula over here, where the W is our work, and the work is the force times the distance in the direction of the force. So this cos of theta is the angle between the force and the direction of the motion. Now obviously if that is 90 degrees, then the cos of theta is 0, there is 0 work. But if theta is equal to 0, then cos of theta is equal to 1, then it's just Fs. So this is your work, this is measured in joules. The Ek here is your kinetic energy. That is your energy due to motion. due to motion. Sorry about that. And that's an energy. Now, when you do work on an object, often it will be that it would have gained kinetic energy. This formula can be written like this, because if we've got EK is equal to a half mv squared, I can rewrite that as mv squared over 2m. Can you see that these two things are equivalent? Because I've got m squared and I divide by m, I get this m, and divide by 2 is the same as multiplying by half. And this mv is your momentum, so it's p squared over 2m. So quite often we look at the kinetic energy in this form, that it's the square of your momentum divided by 2 times the mass. This over here is your potential energy. This is the energy due to position. As you raise the height, you give it the potential to do energy. Now, power is basically the general way that we define power is equal to work over time. It's the rate of doing work. But obviously, because if we write this power, I'm just going to use power full because we already use P for momentum. Work is equal to force times the distance divided by the time. We see here that we get s divided by t, distance divided by time, is a velocity, so that's where you get the force times your velocity comes from. And finally, this is all to do with circular motion. This final bit over here, actually maybe let me just clear this all and move this up slightly so it comes into view a bit. This formula over here is to do with circular motion. We have, this is the same formula, because if you're going in circular motion, sorry, excuse the circles, probably won't be very good, of a distance r, then we can write the velocity as equal to 2 pi r, which is actually the circumference all the way around, divided by the time to go one complete circumference, which we use t, which stands for the period. So it's the time taken for the complete period. So if I put that into that formula, I get a is equal to v squared, and it's that's 4 pi squared r squared over t squared, and I divide by further r. This r cancels with that, and I get 4 pi squared r over t squared. Now obviously from Newton's second law, we've got force is equal to mass times acceleration. Therefore we can write force is equal to mv squared over r, or F is equal to 4 pi squared mr over t squared. And this is the centripetal force. This is the force that is required to keep the object moving in a circle. Okay, so those are the major formulas that we have been discussing in this section and in Unit 2. Thank you.